I'm Sam STEHLE. I'm a postdoc in the Building City Dashboards project at Maynooth University. I'm a trained geographer, specifically a geographic data scientist. So my talk will mostly consist about data, spatiotemporal data, and hopefully by the end, both implicitly and explicitly, we can talk about the ways that visualization and city dashboards in particular help ease the transition into a trusted statistics from IoT data. City dashboards come in many forms. There are a couple of similarities, though, that they take. We see a couple of examples here that are utilizing transportation data in real time. We have static statistics or monthly or even yearly statistics in some of these other examples. We also have benchmarking, keeping track of these statistics over time, measuring progress towards goals, towards specific benchmarks. So despite some of these similarities, there aren't standardized designs for dashboards, save maybe a couple of companies that are standardizing doing for cities, creating dashboards to plug their data into. In the eyes of some users, what really makes a dashboard is a dynamic visualization, which means real-time data that's updating as the sensor is collecting it. So again, transportation is one of the big applications here. In some cases, that means moving objects, tracking vehicles, tracking objects through space as they move, as the middle example shows. But in other cases, that means static sensors that replace old data when new data becomes available. So we would agree on our team, our research team, that real-time data is critical, and so do users we've spoken to. I'll get to that in just a second. So as I mentioned, there are some standardized uses for city dashboards, and this list comes from conversations that we've had with users from a user study, asking actual dashboard users how they use dashboards, and these are some of the common threads. We have people creating monthly reports from data, comparing to other cities, benchmarking, as I mentioned, and as simple things as making transportation decisions, from getting from one place to another, utilizing some of that public data. So in this study, we asked several users and to place themselves on a scale of knowledge and experience with dashboards. And so the important point here is that there are a lot of different experiences that come with users of dashboards. There come from novices who might just be using this IoT data to navigate the city, using transportation, up to professionals who are regularly using this as their front end to IoT sensors. So the way I see it, there is a role that dashboards and visualization in dashboards play in converting from real-time data to official statistics. And this is sort of maybe the implicit part where a lot of these things must happen, and dashboards have one role to play in easing this transition, making data usable, which I see as central to trust and creating and building trust in those statistics, in that data, in those statistics. So how frequently is the data being created? How responsive is it to what it's trying to sense? How does it compare to other data? And that's one of the things that we're trying to do. We're trying to standardize dashboard design. We're trying to determine what visualization strategies can help do this. So I have a couple of examples, and these are drawn from a study that I did, which will be published in the International Journal of GIS, Geographic Information Science. It's in the second round of revisions. I'll get to that in a sec. So considering these roles that dashboards play, multiple roles, in combining real-time data, in archival data, comparing across different places, across different times, presenting the image of a city, incorporating novice and advanced professional users, interfacing between these data and making important decisions. what sort of design features can we discover, can we implement to help increase this trustworthiness. So before I get to some of those designs, just a quick note on what I see is central to trust in real-time data is the idea of real-timeness, and that involves several stages on the way from sensing data to presenting it, including sensor latency. How often does it collect data? How does the interface render of that data? So these are some of the things that I think are important to keep in mind and sort of underpin a lot of these strategies. So I have a couple of slides on some of the strategies that dashboards do use to increase trustworthiness. These are all derived from an extensive survey on dashboards that, or dashboard-like systems that do incorporate real-time data, visualize it, and specifically for the public. Again, some dashboards are private. They're used only by city and by authoritative members of the city. But one of the strategies is whether that visualization incorporates new real-time data by a manual selection, a manual refresh, or an automatic replacement of old data, as you see in the example on the right. These have their advantages and disadvantages, and really most, I would say, a vast majority of dashboards are using the automatic refresh option. They're not taking a manual option, and I think there's a major problem with that, and that is change blindness and the inability to detect if there was a change, and especially the magnitude of that change is sort of, it's been proven that users can't know that. So this is a big problem, even though users have a stated desire for automatic dynamic data that they don't have to interact with. So given that we do have an automatically refreshing web page, we have to display some of the metadata of those sensors, which is how frequently has it been updated? When was it last updated? How old is this data that we're looking at? When can we expect the next update? And so these aren't mutually exclusive. They can both be implemented, but they have their own sort of advantages. And one question that I continue to think about is whether this implementation of this of visualizing this metadata is independent of the sensors themselves. Whether the visualization has its own idea of what is happening. Is it querying an API at a certain given time? And if that's the case, how can we prove the data veracity from those sensors if the visualization itself is separate from that data generation process? And I don't think we currently demonstrate that difference, whether there's a divide there or not. And so veracity is still an open question. The other important, or the final important visualization method would be incorporating historical real-time data or archival data, which enables a new context, provides a new temporal context for current measurements, as well as other things like detecting periodic patterns, which are frequent at multiple scales in the city, at the daily scale, at the weekly scale, and the seasonal scale. So being able to change the duration of an archive, of a real-time archive, would really help to visualize that. And a couple of examples here show a previous full cycle, so yesterday's data, and that provides additional context for comparing to what is happening right now. And I think this is really important because we can't rely again on change blindness and on our own ability to interpret plots in most cases. Another similarity really quickly that I think can be incorporated into dashboard design is this idea of situational awareness, which is a visual analytic strategy for interacting with real-time data in order to rapidly make decisions in the cases of disasters and things. So this is a combination of spatial, temporal, semantic, ontological properties of real-time data, which has to be presented in a way that decisions can be made now. So I think this is a sort of an underutilized connection that dashboards can and real-time visualization can make. So as I only showed you a couple of examples, but in this research, I've derived a whole list and of different visualization strategies and what they can do to help promote trustworthiness. And in linking that with and helping merge that with the user study that we've done, we're finding a lot of quotes that speak to specific strategies here. Users want less interaction in order to get information. They want an automatically refreshing page. They want to see data happening more often. It is sort of a trustworthiness statistic when data is coming more frequently. If you have to wait for a very long time, it feels like suddenly we're not in real time anymore. They want to see indicators. They want to know. They want to see that metadata. They want to see that things are moving, things are happening, changing in the city, and they want maps. They want spatial data, and they want that to be upfront. That's the major comparison, which makes me very happy as a geographer. But I think dashboards still don't do that enough. So that leaves several remaining challenges. It said change blindness is a huge one. I think we don't have a solution for change blindness in any case, but it hasn't been tested as a real-time phenomenon. Whether that impairs your ability to make meaning, to make usable data. Archival storage, the more data we're collecting, the more we have to save it, and over time that gets very restrictive. We want to encourage pattern analysis spatiotemporally. We have to maintain the infrastructure, which the dashboards often are not doing. They're front end to the APIs, which and so. As we find a lot of the cases, some of the dashboards I've shown you are old screenshots because they don't work anymore. the APIs aren't working. It's because they're separate from the two. And again, we want to move to insight, which is comparable over spatial contexts, temporal contexts, and that'll make a statistic more usable. So, thank you to our funders, the Science Foundation Ireland, and I'm happy to take questions.